بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. This is Stat 101, Major 1, Term 232. Let us have a look to the exam and solve it together. First part, multiple choice questions. Assuming you have data for a variable with 3,700 values. Okay, so the data has 3,700 values. Using the 2 to the power k greater than or equal to n guideline, what is the smallest number of groups or classes that should be used in developing a grouped data frequency distribution? When we construct a group data frequency distribution, we have to determine first the number of classes. And usually it's something between 5 and 20. And we can follow this guideline, where n is the number of values in the data. So n here is 3,700, and k is the number of groups or classes we need to find. So 2 to the power k should be greater than or equal to 3,700. Now, how can we solve this inequality? How can we find the value of k? We can take ln of both sides. And then we know that one of the lens properties, this k can come outside. So we can write it k times ln 2 greater than or equal to ln 3,700. And to find k, we can just divide both sides by ln 2. So ln 3,700 over ln 2. Now, if you use the calculator to find this number, you will find it 11.8533, and so on. So k should be a number greater than 11.8, and its number of groups, so it has to be an integer. So we choose 12. We can choose 12, 13, 14, but he is asking about the smallest number of groups. So 12 is the correct answer. Your favorite color is an example of. So color, what is it? Is it a nominal type of data, ordinal, interval, or ratio? Ratio and interval for quantitative data when there are numbers. But colors, we will have yellow, blue, no numbers. So either ordinal or nominal. Ordinal when you can order the categories. So which color is first, which color is second. Of course, there is no such order for colors, so the answer is nominal. A data set of unemployment rate in different cities of the Kingdom of Saudi Arabia is, okay, unemployment rate in different cities of the kingdom. Is it time series? Well, it would be time series if it is taken every year, for example, or every month. So successive time. Uh, Cross-sectional if it is taken in one specific time. And that's what it appears here because he didn't say every year or something. So the answer is cross-sectional. What type of variable is the number of restaurants in your city? Number of restaurants attribute, this is nothing. Continuous, discrete, qualitative. Of course, it's not qualitative, it's either discrete or continuous. Since it's number of, it is discrete because we will have 3 restaurants, 4 restaurants, not 4.1, for example. For the following data, the 30th percentile and 70th percentile. Well, to find the 70th percentile and the 30th and any percentile, we need first to find the index. And the definition of the index is P over 100 times N, where N is the number of data. How many data we have? 2, 4, 6, 8, 9. So N is 9. P at the 30th percentile. So it is in fact, I would be zero point 0.3 times 9. 0.330 over 100 times N, which is 9. The answer is 2.7. If I is not an integer, you round it up to the nearest integer, up. So the third position. So the number in the third position would be the 30th percentile. But we need to arrange the data first. So the smallest is 20, then 23, then we have two 25s, 28, 30, and 8, 29, 38, 39, 41, 44, 2, 4, 6, 8, 9. These are 9 numbers. The third number, 1, 2, 3. So P3, B30, sorry. The 30th percentile is 25. Similarly, to find the 70th percentile, find I, which is zero point 0.7 because 70 over 100 times 9, and that's 6.3, not an integer, so round up to 7. So 3, 4, 5, 6, 7. So P70 is 39. So the answer is part C, 25 and 39. Divide the population into subgroups according to some common characteristic, then select a simple random sample from each subgroup. That's exactly the definition of stratified random sample. If you select one group or two groups, it's cluster. If you select from each group a random sample, this is a stratified random sampling. Construct a pie chart. Well, to construct a pie chart, you can find the degree or you can find the percentage. Okay, let me this time find the percentage. To find the percentage of each level, I have 3,400 freshmen. So I need to know the total. What is the total of those students? So if you add all of these numbers, you will find that the total is, uh, okay, let me use the calculator, 11,450. And now how to find the percentage of freshmen? You divide 3,400 over 11,450 and you multiply by 100 to have it as a percentage. If you do that, you will find that the percentage is 29.7. Do this for all numbers. So this would be 27.2, and this is 20.5, and 1,830 over 11,450 times 100 is 16. So this is 16%, and this is 6.6%. If you add all of these percentages, you will find the total is 100%. So pie chart, it's a circle, okay? And in a circle, we have 4 quarters. So half of the circle would be 50%, and the quarter would be 25. So 29.7, something like 30. If I start from here, it 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 has to be something like this. Okay, more than 90 by just 5%. 5%, well, this is 25%, so divided by 5. Okay, so 5 pieces. Yeah, if you want to take it more up to here, for example, it doesn't really uh, change. It is okay. Okay, so I will write here F for freshman, and 27.2 I will take it from here, from below. So just also greater than 25 by small percentage. This is sophomore. Okay, and now 20.5% for junior. Well, if I add 20.5 plus 29.7, because this is 29.7 and this is 27.2. If I add 20.5 plus 29.7, I'll find that the answer 50.2. So 50.2 means almost 50. So this could be junior, okay, which is 20.5. If you want, you can make it like this, somehow greater. These small differences are not really that important. And then 16%, well, here I have about 25, not 25, 23. So 16, half of 25 is 12.5. So 16 would be something like here. So I can say that this is senior, which is 16%, and this is graduate, which is 6.6%. So this would be okay. This is uh, a, a pie chart or pie graph. Calculate the standard deviation for the following data points. Well, the formula of the standard deviation, it is S equals square root of summation x square minus summation x all square over n minus 1. This is one formula. Uh, if you add summation x square means 4 square plus 1 square plus 7 square plus 4 square plus 5 square. Use the calculator. You will find that the sum of all the squares is 116. And if you add the numbers 4 plus 1 plus 7, it would be 24. So 24 squared over n, which is the number of data, 2, 4, 6. I have 6 data over 5. So 116 minus 24 square over 6 all over 5. Inside the square root, you will find that the answer is 2. Or you can use the formula summation x minus x bar square over n minus 1, also inside the square root, because we need the standard deviation, not the variance. Well, x bar here, you add the data and divide by 6. So you will find that x bar is 4. And here you add the difference between every every element in the data and x bar, and you square it. So for example, 4 minus 4 squared, so that's 0. 1 minus 4 squared, that's 9. 7 minus 4 squared, that's 9. And 5 minus 4 squared, that's 1. 3 minus 4 squared, that's 1. 4 minus 4 squared, that's 1. So you will have 9 plus 9 plus 1, that's 20. N minus 1 is 5. 20 over 5 is 4. And the square root is 2. So the answer is 2. For the following data set, construct a stem and leaf. The minimum number in the data is 0, and the maximum is 34. So I have two uh, digits. I will use this digit for stem and this one for leaf. So I can say 0, 0. So the stems will run from 0 to 3. So I have 0, 1, 2, 3. These are the stems. And now the first number is 0, so I write 0 here, 0, 0. 1, so I write 1, 1. So this is 0, 0, 0, 1, 0, 1, or 1. 10, 1, 0. I have also 12. I have 20, 23, 24, 29, 29. I have 30 and 34. 3, 5, 10, 12. I have 12 numbers, so I didn't forget anything. So this is the answer. Data was collected on the number of television sets in a household, and it was found that the mean was 3.5 sample. Okay, so X bar is 3.5, standard deviation, that's S 0.75. Calculate the coefficient of variation. Well, CF by definition is S over X bar times 100%. So S is 0.75 over 3.5 times 100%. Put it in the calculator and you will find that the answer is 21.4%. So the coefficient of variation of this data is 21.4. Below is a group data frequency distribution. These are the classes, these are the frequency, relative frequency. Complete the table. Let us find the relative frequencies. How? We need the total. 15 plus 15, that's 30. So to find the relative frequency, you divide 4 by 30. 4 over 30, this is 0.13. 11 over 30, that's 0.37. 12 over 30 is 0.4. 3 over 30 is 0.1. Cumulative frequency, you add the frequencies. You start by 4, and then you add the 11, and then you add the 12, and then you add the 3. He may ask for cumulative relative frequencies. So you start by 0.13 and add. Draw the frequency histogram. He needs histogram and frequency. So, for example, here are the classes, and here is the frequency because he asked for a frequency histogram. The classes starts from 5 to 25. So this is 5, 10, 15, 20, 25. You can take each two as you wish. If we say that this is, uh, we need it up to what? Up to 12. So let us say that this is 2, 4, 6, 8, 10, 12. You can take it. You can make it as you wish. So the first class, the frequency is 4. So this class has a frequency 4. The next one, 11. The next one, 12. And the last one is 3. So this is the frequency histogram. The following data set is the prices in real, okay, for different brands. Calculate the mean. Well, the mean is summation of all the data over n. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12. Add all of these numbers by the calculator. 2 plus 9 plus plus. The total is 161. So the mean is 13.4. To calculate the median, I need to arrange the data. Smallest is 2. I have 5, 5. I have 9, 9. I have 12, 3 times, then 19, 21, 25, and 30. 2, 4, 6, 8, 9, 10, 12. Good. The median will be in which position? Well, I have 12. So 2, 4, 6, it has to be here. 6 to the right, 6 to the left. Although you can find it by the index 0.5, 50 over 100 times 12, that's 6. Now I have an integer. Whenever you have an integer, which is 6, 1, 2, 3, 4, 5, 6, this is the number in the sixth position. You take the number in the 6.5 position, which means you add 12, this number in the sixth position, plus the next number, which is in the seventh position, and you divide by 2. So the answer is 12. So the median is 12. The first quartile is the 25th percentile. So 0.25 times 12, that's 3. Also, where is the number in the third position? You can also see that here is Q1 and here is Q3 because you have 12 data. So 3, 3, 3, 3. Okay, it's 25% to the left of the quartile. Anyway, 3 means this is the third, this is the fourth position. So Q1 would be 5 plus 9 over 2, which is 7. The third quartile, the index 0.75 times 12, and this is 9. So 6, 9, 10, between 19 and 21. So Q3 is 19 plus 21 over 2, and that's 20. Draw the Box-whisker plot for the above data. Well, I need to find the lower limit and the upper limit. The definition of the lower limit, it's Q1 minus 1.5 times IQR. Well, IQR is Q3 minus Q1. So it's 20 minus 7, so that's 13. Q1 is 7 minus 1.5 times 13. If you use the calculator, this is negative 12.5. The upper limit is Q3 plus 1.5 IQR. That's the formula. So it's 20 plus 1.5 times 13, and this is 39.5. So the upper limit is 39.5, and the largest value in the data is 30. So I need to go up to 40, and the smallest data is 2. And these are prices, so I can go to 0 or there is no negative prices. So I'll just go from 0 to 40. So 0, 10, 20, 30, 40. So this would be 5. This would be 15. this would be 25, and this would be 35. So Q1 is 7, so it's somewhere here. This is Q1. Q3 is 20, so this is Q3. And this is the rectangle, the box. And the median is 12. The median is 12, so it's somewhere here. This is the median. And the whisker goes to the upper limit, which is 39.5. And this will go to the smallest possible value, which is 0. If you want to take it to negative 12.5, you say up to here. That that's would be also okay. You can do that and that. Let me take it to what is 12. So somewhere here, negative 12.5. This was the last question. I hope you enjoyed uh, solving this exam with me. Have a nice time and see you in other exams.